Okay, the last section in Chapter 2. So Chapter 2 is all about financing. And so the last section, actually, it's a fairly big last section. It could be broken down into two sections. There's basically three big ideas. There's the sinking fund or accumulation annuity. Then there's just general annuities, and then there's loan type annuities. All right, and again, this all has to do with how we're investing money, how we're taking out loans, pensions, and those kind of things. All right, so annuities, loans, and sinking funds. We actually start with the sinking fund. What a sinking fund is, it's like a savings account or a money market account or an IRA or a pension. That's how pensions work, your 401k. Is what you do is you sink money into an account. So it's also called the accumulation fund because that's literally what you're doing. You're accumulating a bunch of money over a time period. And how you're accumulating it is you're making regular deposits. And if it's a 401k, both you and your employer typically make regular deposits into an investment, right, into some type of annuity investment, over the same time periods per year. Most of the time it's monthly, although it doesn't have to be. A lot of times in businesses it can be quarterly or things like that. The idea, though, is you're depositing the exact same payment every single pay period. So if it's monthly, every month you're investing the exact same amount. So suppose I want to save $100 a month. And so every month I put $100 into an account. And so I'm accumulating by putting more money in every month. And every time I put money in, my money gets compounded. The interest gets compounded. And so the compounded period is also the pay period, right? I get to earn money on the new money that I put in, plus all of the old money that was in there, plus any interest that I've earned up to that point. So it's accumulated function and it's compounding interest. The account always starts with nothing in it. And so this is actually important when we go to the TVM solver. If you're accumulating stuff monthly, you assume over the first month in your account, nothing's in there. Then you make your first payment at the end of the month. And so for the first month, $0 in there. And then you make your first payment, put $100 in. And the second month, you put another $100 in. So you have $200 of your money plus any interest you incurred over that second month. And then you do the same thing for the third month, the fourth month, and so on. And so present value is nothing. It's the payments that are going in. And so when we go to the TVM solver, present value is going to be 0. And now I'm going to have something to put into that PMT spot in the solver. And so again, your amount's accumulated by making regular payments while at the same time compounding interest. And compounding in your payment period should be the same because every time I put money in, there's more money in there that's reinvested. So it's compounding over the amount of time I'm putting new money in. Alright, so the formula. So again, it's always a good idea to understand how the formula works, the accumulation formula works. Alright. Now, I will do one example with the formula, and then the rest of them I'm going to do with the TVM solver. I'm going to assume most of you will do, and I encourage you to do the TVM solver. But you should have at least the basic understanding of what the solver is doing. It's solving this formula. Alright, so here is the sinking fund formula, and so it's solving for a future value. And if you'll notice, nowhere in the formula is there a present value, because present value is 0. Right? There's $0 at the beginning. There's nothing in the present amount. Alright, then I've got my future value, which is the large amount of money I've saved by both plugging money into the account and earning interest on the money I've plugged into the account. And then, so there's the payments. PMT is the new one. So that's the every, month I'm putting money into the account. So those are the regular payments. PMT, the regular payments per month. Deposits into the account. And so that's the new part, the PMT. And those are the small money amounts that I'm plugging in overall every time. And then the I and the N are the same. So inside here is basically, again, this is a more complex formula because more stuff's going on with your money. You're putting in regular amounts every so often. You're earning interest not only on the amount you put in, but all of the previous amounts that were in there, plus all the interest that you earned up to that certain point. So again, you earn interest over every pay period. And so the next month you get the previous pay periods plus the interest plus the new amount in there. And so that's what's happening in this formula, which is why it's more complex. And so inside here is your 1 plus I, and I is the interest rate per compounding period. So remember, we find that by taking our interest rate divided by M, the compounding period. N is the total number of compounding periods. And now N is actually very significant. All right? It's the same N that's in the TVM solver. It's our compounding period times time. And what N represents is the number of payments you make over the time. So that's going to be important when we go to figure out interest. This would be, so if I took N times the PMT, that's the total amount of your payments. Right, it's the, not doesn't include the interest, it's just your payments, right? You're putting this amount in so an example would be, suppose I wanted to put I'm saving. I want to put $100 in every month for 2 years. So every month I put $100 in over 2 period. Well, that's 24 months. So 24 times I put $100 in the account, which means 24 times 100, I put $2,400 into the account. That's how much money I invested. Then I'll earn interest, so there should be more than that in the account. The extra is the interest. All right, and so that's what we mean by why the N is important. It's telling you how many payments you're making. Which is also important when we get to loans. Same thing for loans. All right, so the formulas is important. Again, you can use the formula, and the book talks about it in a little more detail. I'm going to assume that you're going to use the TVM solver, so you don't have to solve it with the formula, but I'm going to do one example so you at least see the formula in use one time. Some people like formulas, and that's fine if you like the formulas. But like I said, after this, I'm going to do the TVM solver and show you how to plug it in there, and then I'll be using the solver for the rest of mine. Alright, but what the solver is doing, it is solving the formula. Alright, so the formula is your regular payments times 1 plus I raised to the n minus 1 all over I. And I did write it this way because that's how you have to plug it into the calculator. You have to put parentheses around the top part. Now, you don't necessarily have to put parentheses around the I unless you don't simplify it. Alright, so payments. Well, Andrea makes regular deposits. So every 6 months, which means twice a year, and it's 2, she's going to put $1,000 in the account. So remember, over the first 6 months, it's empty. Nothing in there for the first 6 months. Then she puts $100 or $1,000 in there. And then the second 6 months go by, the end of the year comes along, and she puts another $1,000 in there. Alright, so those are the regular payments. So she's putting $1,000 in every 6 months, so twice a year, semi-annually. It's earning 5% interest compounded every 6 months. Again, that compounding period is exactly the same because the money's reinvested. Alright, so every 6 months you're putting $1,000 in, and so the next 6 months you put another $1,000 in. Well, you get to accumulate. You get the previous 1,000 plus any interest plus the new 1,000. Right? And it should match up. Compounding period and payment period are exactly the same. Alright, and so our interest rate is our 5% compounded twice a year. How much money will she have after 2 years? So time is 2. Alright, so remember, this involves the N and the I that are in here. N is our compounding period times time, so it'd be 2 times 2. And so she makes a total of 4 payments, which means she's putting 4 times, she's putting $1,000 in the account. So based on that, I know the amount should come out slightly bigger than $4,000. Not a whole lot, alright, because it's not very long, but I know it should be over $4,000 because $4,000 is her money. Right, then the I part, remember, is our interest rate over a compounding period. So I is our 0.05 over 2, and that simplifies nicely to 0.025. Alright, so there are the values that I plug into my formula. Alright, so my payments, $1,000. 1 plus I, 0.025, raised to the 4 minus 1 all over I, which is 0.025. So the parentheses you need are around the subtraction in the numerator and around the addition. Now, if you add that in your head, you don't necessarily need that set of parentheses, but I always think it's a good rule of thumb to do that. Extra sets of parentheses are just always a good idea. Then you carefully plug it in, and it should come out slightly more than $4,000, and it does. It comes out $4,152.52. Remember, $4,000 is her amount, right? She put $1,000 in 4 times, And so the $152.52, the extra, that's the interest, which I believe we'll answer in the next question, interest question. All right, so that's the formula. Now the calculator part. And so remember, the calculator is solving that formula, but it's a program, so I have to make sure I carefully plug it into the program. All right, so there's again, it's the same place. It's under the app key, finance, go into the TVM solver, and we have all the same things that we did before. All right, suppose that you plan to deposit $100 every month into an account earning 4.5% annual interest compounded monthly, because you're putting money in every month. How much money will the account contain in 10 years? How much total? So we'll figure out the total interest last at the 10 year, after the end of the 10 years. We'll figure out future value first, and then we'll figure out interest second. All right, you plug them into the calculator the same way we did before. I and N, and then these are all the same. So I'm going to start there. N is still our compounding period times time, so it's monthly is our compounding period. Time is 10 years, so 120. So that means she's investing $100 120 times, right? Every month, 12 times a year for 10 years, you're putting $100 in the account. I is still your compounding interest, goes in there whole as the whole number, 4.5. Right, I'm going to skip over these for a second. I'm going to come down to the bottom. Now, these are going to make a little more sense why there's two of them. PY stands for payments per month, payments per year. Sorry, in this case it's monthly, so it'd be 12. And CY is compounding period. Well, that should match, right? That is also monthly. So that's why those two always match up. And then it should be by default highlighted at the end. So you should be fine there with that. Alright, so payments at the end, 12 times a month, and now the middle stuff. Alright, so remember, there's nothing in the account in the beginning. So present value is 0, right? The account is empty when you open it, so nothing in there initially. And then at the end of the first month, you put your first $100 in there. All right, so your payments, and then here, why is the payment negative? You do plug it in there as a negative 100. All right, well, the reason why is the same reason the payments were negative, the present value was negative in the original, in the 2.2 stuff, the compound interest stuff, is because it represents the amount of money you are giving someone else, like a bank. You're taking the money out of pocket, right? Out of your pocket, and you're plugging it into the account. Since you're paying into the account $100 per month, you can't spend it. You're investing it into this company, and they're putting it in the stock market, or they're giving out loans with your money. They're using your money, and while they're using your money, they're paying you for that. That's what the interest is. They're paying you to use your money. And so while it's invested over that 10-year period, you can't touch it until the end of the 10 years is up, and then you can go in and take the money out. That's why pensions and 401ks and IRAs typically have a time limit. You can't actually take that money out without penalty until you reach retirement age, which is around 65, 67 now, where you can get into your IRA, get into your 401k. All right, because you need to leave it there while other people are playing with it, so to speak. And you can't touch it, so it's negative, right, because you can't spend it. All right, so your payments are negative. All right, then the last thing is, well, we're solving for the future value. So remember, this is what we're solving for. So you highlight that, you hit second enter and solve, and it will tell me how much my future value is at the end of 10 years. So after 10 years of investing $100 into an account every year, every month, for 10 years, so 120 times, it comes out $15,119 and about 81 cents. Right, so that's how much was accumulated, right? So it's also called the accumulation function. So we accumulated a little over $15,000. Now I want to know how much of that $15,000 is my money, and how much of that $15,000 was the extra that I earned from my investment, right? We want to figure out interest. And so to figure out interest, well, this is where you sort of have to figure out what it is. So the interest in this case would be you take the future value and subtract all your payments. All of them. You made 120 of them. And so this is the future value minus the end value times the payments you made. Right? 120 times you put $100 into this account. And so we take our future value, which is at 15,000, minus 120 times 100. And so that's 12,000 right there. So $12,000 is your personal money out of pocket. So you take the 15,000 minus the 12,000 and the difference, the extra, which is the interest, and so you earn $3,119 and about 81 cents in total interest on this investment. All right, so it's the extra. So we'll stop there. We'll continue on with practicing these cases in the next video, and I will be using the TVM solver to set it up. So I'll be using this, but if you're a formula person, you can also use the formula. The biggest thing with the formula is just make sure you're careful. Always rule of thumb is have those extra set of parentheses in there. All right, we will stop there.